Hello. So today we're going to figure out how to derive the power reducing identities. And so all you need to know for this is you need to know the Pythagorean identities and the double angle identities. And you can figure out pretty much all the other trig identities that you need, so you don't have to memorize the whole entire sheet. And so I wrote the double angle identities here. And I can show you quickly how to figure out the other Pythagorean identities from this one. So if I took this and divided everything by sine squared theta, that would give me 1 right here. Cosine squared over sine squared is going to be cotangent squared. And 1 over sine squared is going to be cosecant squared, because that one is a reciprocal identity, right? That's this one, if you don't remember. Those are a separate thing. So that's our next one, and then we have one more that we can get from here. If I divided everything by cosine squared theta, sine over cosine would give me tangent. I'd have tangent squared theta right there. Cosine over cosine, that's going to be 1. And then 1 over cosine is going to be secant squared theta. That's another reciprocal identity that you probably should know. So I have these three. So to figure out the power reducing identities, I'm going to start with the double angle identity. I'll start with the cosine one. Cosine 2 theta equals cosine squared theta minus sine squared theta. And what we're basically going to do for these is our answer needs to be something. We need to have an expression for a cosine squared or a sine squared so that you can substitute that expression into problems whenever you need it. So for this one, I can rewrite the cosine. If I look at this one and I subtract the sine, I have cosine squared theta equals 1 minus sine squared theta. I'd have this. So then we have an expression for cosine squared theta. And I can write that in here like this. And if we just combine these together, I'll have 1 negative sine squared theta minus sine squared theta is negative 2 sine squared theta. So I'll have this. I'll bring this down here. And so then I need to isolate the sine squared theta. So I can divide by 2. I can divide everything by 2 to get that 2 off of there. So then I would be left with this. And then Now I can just add the sine squared over here. And I can subtract this one. I can subtract this one so that I've isolated the sine squared theta. So then I'll have sine squared theta equals 1/2 minus cosine 2 theta over 2, which is, they have the same denominator, so we can just write that as 1 minus cosine 2 theta all over 2. And that is how you can get the power reducing identity for sine squared theta. So now I can I'll do cosine squared. So for that one, we're going to start off with the double angle formula for cosine again. And instead of substituting a sine into the problem like we did here, we are going to substitute a cosine into the problem. So for this sine right here, I can use this identity and I can say cosine squared theta equals, I can say sine squared theta equals 1 minus cosine squared theta, just by subtracting this one over here. And that gives us an expression for sine squared theta so that we can substitute it in to here, and now we only have our problem in terms of cosine. So I'll rewrite that here. We'll have this. And don't forget the minus sign. And if you distribute that negative sign, you're going to have a positive cosine. So you're going to have 2 cosine squared theta. We just add them, and then we're going to have -1. And then it's just the same thing as the other side. We have to get rid of the 2 on our cosine so we can divide everything by 2. So we'll have this. And then this one is positive, so we can leave it there. We need to add the 1/2 to the other side. So then we'll have this. And they have the same denominator, so we can just write it like this. And that is your power reducing formula for cosine. So for tangent, if we need a power reducing formula for tangent, that one's actually way easier, because if you know tangent is just sine over cosine, then tangent squared theta is just going to be sine squared theta over cosine squared theta. And we already found the identities for that one. So for my sine squared theta, it's supposed to be 1 minus cosine 2 theta over 2. And when we're dividing by something, we're just multiplying by the reciprocal. So that would be, my cosine will end up being this. That's the reciprocal of that one. The 2's will simplify, so then I will be left with this. And That is my power reducing formula for tangent squared theta. And it's way simpler than memorizing them to me.